Um, Hi everyone. We are with another session today, and today we'll be talking about the topic of advanced reverse image search and profile creation. Uh, the problem statement says that we have to detect faces in an image. So, for example, if I give you an image, you have to first detect face. If there are multiple faces, it should detect multiple faces. And when the faces are detected, it has to reverse search on the social media platforms, different social media platforms, and find the similar images. After finding the similar images, you also have to find out who the individual is, if at all he's available on any of the social media, and create its profile. So that profile, as in what is the name of the individual there, what is it, whatever public information is available for that individual, uh, you have to do a reverse search and get that details. This is important because there are two things. When we get an image of a person, that okay, for example, let's say we somebody has done an FIR and they say that this person is missing, and when you get an image or a photo of that person, that this person is missing, certain times it happens that people on a public media try to post if some incident had happened, or if somebody is searching for somebody. So all these informations, some of the other pages people try to post, and you might have seen people reaching out to you saying that so and so girl child is found here, or so and so boy child is found here, and accordingly you also uh, try to help and see who this child belongs to. So it can help in that way. It can also help to identify some people who have done something wrong, and there are a lot of things which it helps. Though there is something which is Google search, image search already available, but since we rely on Google, we try to create our own this a short code where we can use it for our own, for the purpose of security, for the purpose of finding people, for the purpose of finding wanted peoples, any purpose which is more or less related to finding of identity of an individual. And also there are certain cases in cyber security, like cyberspace, where you as an individual are being imposted by somebody else. There's an imposter who's trying to use your profile pic or your picture to be identified as somebody else. So the image is yours, but the individual is an imposter. So even it will help to identify those incidents as well. So again, we'll understand what it is, how to do it. We'll see a short demo of it, and then we conclude. So what is reverse image search? It's like a search engine. Okay, you are trying to create a search engine which will discover the information about the image. Whatever image you have shared, it will discover the information on it, find the better quality, bigger sizes of the same image, investigate online appearance and usage of that image. So in this scenario, what are we trying to do is we are using the same search engine technique only and only for the purpose of identifying an individual. How do we do this? See, the reverse search, it understand if I give you a picture and I ask you manually to search it in a book, what will you do? You have a picture in your hand and you have a book. Keep on turning the pages of the book to find if first you scan your photo. So you're scanning with your eyes. Then you scan with your eyes the photo memory. The features of your photos are stored in your brain. The memory cells of your brain. You pick up your book. You open the book and start searching for images which are very similar to the image which I've asked you to search for. So your memory cells have memorized the image, and now you're trying to search over all the pages of your book. If you find in that book, yes, you know that this and this image are same, but if you do not find it, then that's the end. Then you turn on some other book to see if the similar image is available there or not. The same thing when we are on a web, when we work on internet, we have web pages. We have a lot of web pages. Since if we are focusing only and only on social media, when we will crawl the pages as in when we will scrape the pages, or when we will move from one page to another, we will only find it on the web pages which belong to social media. For example, we'll only find it on the web pages which belong to Facebook, which belongs to Twitter, which belongs to um, other different social media platforms, and then extract and compare. So we'll extract the images from there, and then we try to compare. This is one thing which we can do. The other thing is we can use the Facebook and these APIs. The problem with the API is that since we don't know what information is being used in that APIs, so for one-time scraping, it's fine. But for every time, the APIs may create a certain problem. So what we'll do, we can come up with another techniques where we do just an image search using some technique, whichever you want. I'll explain one of them, and only look out for the URLs of a scraped image which comes from social media platform, and try to connect or try to restore or try to save the identity of the person and create a database as and when required to identify somebody if they are present online or not. So the first step, what you have to do is, the very first step, you have to accept the image from the user. So you accept the image, and then you compute the fingerprints of an image using a hashing algorithm. Image, and you create a hash of an image. Hash of an image is a fingerprint of an image which resembles that particular image. So this hashing algorithm can be AI based, can be machine learning based, can be simply based on feature extractions, can be simply based on different techniques for image analysis. We can use one of the algorithms, and I showed you a demo how we can create hash of an image and how we can compare two similar images and find out. Then what we do is we crawl the web pages. We crawl the web pages and create a database, a temporary database of all the individuals' profile pics which are available, and we compare them, we match them. We match the hash of our image to be searched, or a person to be searched, with the person or an image which is available on the internet as and when we scroll. And at the end, we will display all the web pages that contains the image we have queried for. All the web pages specifically from social media platforms. Once we display them, we immediately get into the first link or a second link, whichever is the closest. And when we crawl that link and we can identify a profile, which is name of an individual if available, some identity bio. Sometimes somebody's bio is also available on social media. So all this information we can extract from that particular URL, which has given you the exact same match of a profile picture. If you want to see, I'll just show it to you using Google. I will reverse search somebody's image on Google, and then I'll tell you how Google identifies and gives you the identity of that individual if they exist on any social media platform. Similar thing we will have to also build up, where we can identify the similar face and get the information of that individual. So I'll quickly show you a small thing on Google, using Google, and then our own code using Python. So you might be seeing I'm on Google Images, where it uses an images to search for an image. So it asks you to upload an image. You can either paste a URL or you can choose it from your Windows, your device. And I would see if I am able to put some example up on the screen. And I'll just put this person. And you can see it has given you that the possible related search for this pic is Dr. Chiki Ankuli, and has given the very first link of it, the similar image which exists, visually similar image which is existing, right? What we have to do is we have to follow the same procedure. We upload an image or put it on internet. It should give you, first it identifies how many faces are there, and with that face, multiple faces, it should give you multiple identities. For example, if I just click on this image, this is very similar image to our image, so that is the first one. And when we click on this, now I don't have that image here. So it is saying that it's Dr. Chiki Ankuli, and it is actually it's actually Dr. Chiki Ankuli. Just look into the biographies. So in this, even if an individual is not, I mean, it is giving you that it is a it's a Dr. Chiki Ankuli, and second, I'll just put on my power plug. Just put on my power plug. Okay. So exactly, and we'll have to find the profile. So here it only detected one image, and we have to detect both of the images, who it is, who individual it is, who it belongs to, so on and so forth. And you can see there is an link from Facebook also. So we are only going to target the Facebook, and from Facebook we have found out that one individual on this is Tanmay Bakshi, right? And that's how we have to do an identical search. And you can see this guy is Tanmay Bakshi, and whatever information is available, it's a page, it's maybe a personal blog of Tanmay Bakshi, so you can find out that okay, it's Tanmay Bakshi, and Tanmay Bakshi, whatever publicly available information is there for that individual, you can just list it down and create a profile for that individual. So it's the similar thing we have to do. We will have to create our own content. I will try to pick up an image from internet. For example, I'm going to use, let's pick an individual we want to. Let's pick up Dr. APJ Abdul Kalam, and let's pick URL of one of his image. I'm going to take one of his image. I'll copy the URL, copy link address. Let's go back to Google image search by image. I'm going to paste the URL. It's not showing me. Let me go back. Let me again type Dr. APJ. So I'm going to open the link, copy the URL of the link of the image. Open image in new tab. This is the URL of an image. I'm going to do a reverse search engine on Google. So here is an image. I'll paste and upload it, and it will search and tell me that the possible related search is Abdul Kalam wallpaper. So it's a wallpaper of Abdul Kalam. And you can see if I go and from the available links which has come after I'm scraping this, it's actually giving you the links. So from the available links, I'm only interested in the social media URLs. And from the social media URL, you get that this person is APJ Abdul Kalam, possible things, blah, 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 whatever information is available. We will be using that. We'll be keeping that information with us and storing it in our platform. Okay. Now let's see how we can do the similar thing using Python or any language you can choose, but I'm going to work with Python because I'm more comfortable using Python with data. So I'm on Collab. I'm going to create a new notebook. This was image search. Okay, and slowly I'm going to list down the codes, the libraries which we'll be using for Python. We'll need cascade files, so for feature extractions, and I'm going to import all these files. I'm going to import NumPy. I'm going to import CV2. I'm going to import NumPy. I'm going to import CV2 library, which actually detects which works on image OpenCV. I'm going to request, which will actually go to URLs, web browser to detect, act as a web browser, and URL lib, which will work with URL as well. from it. As I told you, the first thing for me is to be able to uh, get the cascade file. So I'll have to upload the cascade file here. You'll have to create your own system. So your system will have all these files already. So I'm going to upload the cascade file. Uploading the cascade file here, which will actually detect my faces, facial features, face cascade file I'm going to upload. And I've uploaded the face cascade file, and I'm going to pass the view. I'm going to pass the path. This is the face cascade file, which you'll find it on the internet. It is a cascade filters to detect your faces. You can use any of the mechanism for face detection. I'm using the very simple technique of facial features, extract faces. I am going to upload the image, which I'll have to test on. So I'm going to test on images to search for. Upload the image. I'm going to give the path of an image, which is basically the test image, which I'll be uploading. So I'm going to give the path for my test image. And once that is done, now we will go step by step to detect the faces in the image. Since I am using URL, I'm not using any URL. So for URL, you will have to have certain other techniques as well incorporated in this. But I'm putting up a local, I didn't run this, I'm sorry. So here we have an image, and I'm going to import matplotlib pyplot as plt. And if I do plt.imshow and I pass my image, you will see the same image which I have shown you with, like with the Google. I'm going to try with the same image. I have a cascade filter, so I'm going to detect. So I'm going to type the face detection code now and detect my faces. So I'm going to write the code for face detection. hair cascade is one of the technique which we'll be using for face detection. And since you have seen that I am, uh, I mean, hair cascade filters, you will find the frontal features already. But if you want to use your own frontal feature techniques, you can definitely go with that as well. And if you want to go with the available techniques, you can go with the available techniques as well. So we're using hair cascade frontal features for our cascade as a cascade filter. And if you want to learn more about it, it's available in OpenCV library of Python. And okay, you know the best part with writing the code is that we everybody knows about OpenCV. So OpenCV is a library in Python. And when we work with OpenCV, you will find out that this tool has so much to give you, so much to explore within an image. You can detect multifacial images, you can detect one image, you can detect a lot of things in it as well. So we'll be using some techniques, which I will quickly write it down. From sky image, we will import data. Search, uh, we have trained the file cascade filter. We have used the trained file, which is a cascade filter for us. And now what we'll be doing is we will be detecting the faces which we have. So I'm going to just quickly show you how it is done step by step. So we'll detect the faces and we'll see if the faces are being detected or not. No faces are detected. We'll see the plot in our image. So this is our image, and the scale factor, if you change, let's see if then the faces are detected or not. So with minimum and maximum scale size, you are giving what ratio or what is the scaling factor, how, what is the minimum dimension of your face, and everything you're trying to find out. So you can put 505 and try to see if they are detected. If not, then we'll change our image. We'll see the different image. So let's try to put another image and see if we are able to. Detect image. So we're uploading some other image because this image file is not getting detected. So let's copy this and see. You can see the detector is detecting the multi-scale images. I have passed the gray and we are seeing if the image is being detected or not. Let's see if it detects the multi-scale image or not. And once the images have been detected, we will try to search it or reverse search it using Google. And you can see it is saying that there is an image of height 31 and 83. So it is detecting images in our loaded image. So this is our loaded image. Okay. So it is saying that there is an image. So the face is being detected. Let's see if we change to our testing path, test image path, whether it is loading or not. It did not detect with this. So the scaling factor and something, if you keep changing it, it will probably detect the image. It probably detect the faces as well. Okay, so for image detection, you will have to look into a lot of features. For example, you can see that the minimum height is 100 or 50. It's 100. So we'll go with 100. We'll change the min size and max size. So we can keep it as 150, or we can change this to 223 and 223 to be able to detect the faces correctly. So you can see when we changed the maximum size, it detected in our original image as well. So the width of the image has to be aligned in such a way. So you can make it dynamic as well. Since we are doing it, so we put it in manual detection. And since our face is detected, now we'll go ahead uh, with seeing the face, exactly how the face is. So we'll be seeing that. So when we have this, So I'm going to show you the detected face now, and I'm just writing the code for the same. So plt.imshow will give you the image, and then we'll put the image description, and you can see it has detected images from here. So you can see the rectangular boxes of an image, and it is showing you that there are 2 images available in our existing image. So your image is detected. The first step of it is already done. Your image is detected. Once your image is detected, now we will search back the PNG file. So we're going to search back the PNG file. One by one. So I'm going to copy the first rectangular image. So I'm going to copy the first rectangular image and save it. So I'm going to copy just first rectangular image and save it. So it is patch of C, patch of R, and patch of height and width. So I'm going to copy this code and extract only the first image right now. So I'm going to copy the patch code and extract just the patch file now in the faces, from the faces. So I'm just going to copy and extract that. And this is how we do it. It's very simple. How we do that is it is x. So we only need x, y. So x axis, y axis, and width and height. So we need x axis, y axis, width and height. So x is equal to this, y is equal to this, w is equal to this, and h is equal to this. So we do this so that we have our x axis, the y axis, width and height. And from the image we will crop. From the image we will crop. So it's detected of 1. So patch we'll put detected of 1. Detected we have 2, 3. So we'll just put patch patch is equal to detected of 0. Let's put up the first one, and we have this image. We will store it in our faces, this first face. And if you see, one of the image is being extracted. So I've extracted the image, detected the image, and once the image is being detected, I will pass this to my search URL. I'll crawl the web pages where this is existing. So I'm going to crawl it. So we can save it. So if you want, we can just save it. You can just save it, or we can save it with cv2.imwrite thing and then upload it, and you will see that you will get some results. Just 2 steps away from getting the results. We're gonna write cv2 dot I am right. I'll give the name as search.png and pass my image as faces. And now my image is being stored already. Right? So my image is already being stored and I will upload it using my profile. So I'm going to upload and search. So I've last step, we'll upload and search. So I'm going to show you the link where give the file path. You have to search this. We'll upload the content and the complete content is uploading and it will give you the URL. It's going to give you the URL and it has given you the very first URL. Since we do not have browser and collab, so I'm going to copy this and open here. And when you open, you see that it has given you some links on the page, right? And there are some links on the page. We're going to download all the links available on this page. On this page, we're going to download all the URLs. That you can do using URL lab. You can do Beautiful Soup, you can do Scrapy, you can use other techniques to doing this. And you will find the images, the location using so we will only get all the links from this URL. Whatever URL we have got, using Beautiful Soup, we can extract all the URLs which are available on this link. So I'll just show you how to scrape the images from the link. So whatever we have, for example, whatever we have over here, this fetch URL thing, I have copied here. So you can see the same URL is copied here. And in this, you will be getting a response. The response will be the web page actually. Okay. It is a web page. So if you print it out, you will see that it is an HTML web page. doc type HTML. So it has got an HTML web page, HTML scope. It is giving you the entire web page which is here, right? And in this web page, it is giving you href maps as well. So href, all the A links it is giving you. And we want this links, right? We only want this links. Whatever link is here, we just need this links. And we'll extract these links from this URL page. Once you extract these links, right? So we have this, you were crawling. So what we did image detection, we did scrolling. And when we did scrolling, we fetched the URL. Once we fetched the URL, we got and search URL, and then we can parse it and get all the results. So we can parse and get all the results. We can also do the similar thing with Beautiful Soup as well. So we can do the similar thing using Beautiful Soup as well. So I'm going to paste the request over here, the same request which I have done here. So I'm going to do that. So request, I have already given the request, and we can put the same request on Beautiful Soup. I have already imported Beautiful Soup. So from VS4, so I already imported Beautiful Soup. So I'm going to use the same content to fetch the request. And we already have the content above the request thing, which is actually the response. So here we can do the same thing using Beautiful Soup as well. Here we'll pass our request, which we have already copied here, which is multi-cart search URL. It's actually the search URL. We have actually done the post thing, and we can just do the response, the text, because you already got the response. And you can see it has given you the fetch URL response as it is with an HTML parser. And this URL we can again use to get the request. So we can use this to get our request, right? So we can use the fetch URL thingy, which is in our soup, right, to get the request. Yes. So we can do the same thing to get the request, and here instead of post we will do get. So first we'll do post because we are uploading the image. Second, we will do the get on this link which is being provided. And you will see that if there are available for this, it will give you the results. And if not, then it will not give you any results. Results dot text, because response is the response, and then we can have, and you can see it has again given you the whole document of search results. So you can see you have got all the documents of the search results. Whatever has been come up, you've got all the documents. And from here, we will extract the href links. So we are crawling the web page. What are we doing? We are crawling the web page. We got doc type HTML, and I'm going to find all with href. So I'm going to find all of them in the soup with tag A, and I'm going to get href. And you can see on the screen, the heading soup. I have find all A tags. From A tags, I have looped over to get info of href. And you can see there are all the href tags available here. From all the href tags, we will only come up with we'll only search where it is of any social media platform or not. If it is of a social media platform, then we will click on it and get the information. So we keep on crawling the web page after web page after web page to get information which is available on the website. So first thing what we did, I'm going to just go through the code again. First thing what we did is we are using cascade filters for detecting the faces. We loaded the image. We detected the multi faces. 3 faces were detected. The first face we picked up and we saved it. When we saved it, we then searched, uploaded the image and reverse searched it. And when we reverse searched, we got a response. This response, we again gave it back to Beautiful Soup Strainer. When we gave it to a Beautiful Soup Strainer, we got results in our soup, that is an HTML page of a Google search engine. Once we got an HTML page of a Google search engine, we extracted all the href tags in it. Href tags will give you a link to other scripts as well. Once you get the href of those images, then now you will use it. You will filter out the Facebook or social media images and keep on scrolling, web scrolling after scrolling, and ultimately you will get all the information of that particular individual. Okay, so this is how you can, one of the technique you can use for doing an advanced image search technique, reverse search engine on social media platforms to create a content profile. It's the very simple technique. You have to use web scrolling. The different tools which you can use Scrapy, you can use Beautiful Soup, you can use a lot of other techniques as well. That was a short demo of how to extract pages, which will help you from an internet how to upload. So we uploaded the image, detected faces, and how can we create a profile. To creating profile, you can store it in a database of your choice. So you need to make sure 2 things. You know how to detect faces, and you also know how to crawl web pages one after the other. Okay. So there are two things which you will have to take care of, and this one of the idea which you can implement. There will be multiple ideas. You can go ahead with them and build your image search engine. You come up with the different ideas as well. This is one of the technique which you can do. Over to you, sir, and I have completed this topic. If there are any questions, you can put it on the dashboard. I'll be happy to answer you, and you can also ask me personally if you want. So ask me the questions and I'll be able to answer you more. So hurry up and try to open up your ideas and submit your ideas soon. Thank you.